Hi everyone, so today we're going to be looking at solving problems using quadratic relations, and I know we've been looking at quadratic relations a lot, but now we're going to be looking at how to solve problems. So this is where a lot of our questions come from that a lot of students do struggle in, because this is like our application and thinking question. So not just giving you a specific question, but going over and beyond, looking at what is the question asking based off of a scenario. So this is part one, and you're going to learn about part two next week. So we're going to be looking at how to convert between factored form, standard form, and vertex form, which is all the different forms that we have looked at already in the past little while. So some things that we're going to recall is, remember, writing the equation of a parabola in vertex form. So remember, our vertex form equation is our y equals a x minus h squared plus k. So that is always so important to remember this formula. Do not forget it. When we are looking at determining the equation of a parabola in vertex form, given its graphs, the first step that we do is determine the vertex of the parabola and then find the h and k values. So those are always really important to do. Next is substitute these values into our vertex form of the quadratic relation. Then we have to choose the precise point of the parabola and substitute in the x and then the y values of the coordinate in order to solve for a. And then we write the final equation of the parabola in vertex form with the a added value in. So remember, this point that we look at is not the vertex point. It has to be a point somewhere else that is found on the parabola. So remember to recall that we always use FOIL. So whenever we are expanding an equation, when we use factored form, this equation right here, this is our factored form, we must first use FOIL in order to expand our brackets. So we don't want it in the brackets anymore. We want to get it out of the brackets. So this, when we do that and we get it out of the brackets, it's going to transform into standard form, which is represented by our y equals ax to the power of 2 plus bx plus c. So for the example here, we are having our factored form. We want to get rid of the brackets. So what we do is we have to expand. So when we expand, we multiply one bracket by the next. So x times x, 3x is going to give us 3x to the power of 2. And then our x times 4 is going to give us plus 4x. And then we have our negative 2 times 3x. That's going to give us minus 6x. Negative 2 times 4 is going to give us negative 8. We group our like terms together. So our 3x to the power of 2 is not anything similar to anything else, but we have these two like terms. So our 4x minus 6x gives us negative 2x minus 8, and that is our standard form of this equation. So this is recalling things that we've done in the past. So let's look at example 1. So it says the vertex of the parabola is at negative 3 and 2, and the graph passes through point negative 1 and 14. Our part A is find the equation of the parabola in vertex form. So our first step is to always look at what is our vertex, identify what we know. So if our vertex says here it is negative 3 and 2, this can determine for us that therefore our h is negative 3 and our k is 2. Excuse me. So we can determine that because we know that the vertex relates to our h and k values. We looked at that at the very top. That was point 1 from our recalling our steps. Step 2 of this is we have to sub in our vertex form equation. So this is very similar to yesterday's lesson. So this means we have y equals a. We do not know our a, but we know our h is negative 3, so it's going to be plus 3 squared plus 2 because we know our k. Step 3 now is we need to sub in our point that we know, which is -1 and 14, in order to find A. Find A. I don't know why I wrote in order to find A. To find A. So therefore, using the equation that we just had, so our y equals ax plus 3 power 2 plus 2, we have to sub in our y and x values. So we have 14 equals a -1 plus 3 squared plus 2. And now we solve. So we have to solve what is inside the brackets first. So we keep our 14, we keep our a. So -1 plus 3 is going to give us 2, power 2 plus 2. Then we have to move this 2 to the other side because we want to isolate. Remember, we want to isolate. So 14 minus 2 now is going to give us 12. So we'll look at that in a moment once I finish writing this out. 14 minus 2 is 12. And then also what we need to do is we need to get rid of this power of 2. So 2 to the power of 2 is going to give us 4. And then 12, so a times 4 is going to give us 4a. Now what we have to do is isolate a from the 4. So what we have to do is divide both sides by 4. And we will be left with, when we divide 12 divided by 4, we'll be left with 3. So that means a is going to be equal to 3. Now we have to plug in what we solved for a back into our final equation and write out our final equation. So therefore, the equation in vertex form is y equals 3. Remember that 3 that we just solved for? X plus 3 power of 2 plus 2. So that is our new formula. Now it says for B, find the vertex in standard form. Or sorry, find the equation in standard form. So using the exact same equation that we had, which was right here, we're gonna plug this in, but we need to go to standard form, okay? So we need to expand our brackets. So expanding it, we have y equals x plus 3, and then we have to write that twice because it's to the power of 2. X plus 3 again, plus 2. Now what we have to do is we have to expand these brackets. So what we're gonna do is keep the 3 on the outside, x times x, because we have to expand. Remember, expand like we did before, gives us x to the power of 2 plus 3x plus 3x plus 9 plus 2. Now, once again, we have to expand again because this 3 is on the outside, so we have to expand to everything inside. Okay, so everything inside. So 3 times x to the power of 2 is going to be 3x. Oops, I keep doing that. To the power of 2 plus 3 times 3x is going to be, obviously, what we have to do one last time. Because there's 2 3x's here, if we add this together, that's 6x. So 6 times 3 is going to give us 18x. And then 3 times 9 is 27. Oops, don't need to keep the brackets anymore. We just got rid of the brackets. Plus 2. And then we combine our like terms. So 3x to the power of 2 has nothing. 18x has nothing. But 27 plus 2 is going to be 29. So therefore, that is our equation in standard form. Now, let's recall factoring an equation in standard form is key. So in order to factor an equation in the form of y equals, y equals ax to the power of 2 plus bx plus c, we must do the following. So we have to check if a is equal to 1. If so, then we have to find 2 numbers that multiply and equal to c, and then add to equal b, and then the final equation will be in the following form. If it does not equal, if a does not equal 1, if so, you have to find 2 numbers that multiply to equal ac, and then add to equal to b, the final equation will be in the following form. Do note that the a is now added in front here, okay? So this is our standard form, our standard, okay? And then this is going to decomp. So that is very important to remember. So let's do an example. So it says, answer the following questions that are displayed in the graph below. So we have a graph there. Looking at the graph, the first thing we can notice is the vertex. Okay, the vertex here is 4 and -2 because it says that. Okay, it says over here, 4 and -2. So therefore, what can we determine? We can determine our h and our k values are going to be -2 and 4. Our next step, which we did above, is sub in equation. So subbing it in, our y equals a, sub it in, x minus 4 to the power 2 minus 2. We do not know our a right now, but we will find it. Step 3 is going to be sub in any point, and the point that is given here is 6 and 6, so we're going to sub that point in, 6 and 6 to find a. So now because we are able to sub in, we're going to sub in the 6 and 6. So we have 6 equals a, 6 minus 4, power 2 minus 2. Once again, solve the brackets first. So 6 minus 4 is going to be 2, power of 2 minus 2. Now, what is 2 to the power of 2 times a is 4a minus 2. Move this 2 on over. So we're going to get 6 plus 2 now equals 4a. So 8, 4a divided by 4 because we want to isolate our a. And 8 divided by 4 is going to be 2. So therefore, our equation in vertex form is y equals 2. Okay, remember the 2 because we just solved it. X minus 4 to the power of 2 minus 2. Okay, so make sure you understand that. Now we have to find the equation in standard form. So what? Just the exact same thing we did above. I want you to pause now and try it out. Pause now and try it out. All right, the final answer for this is y equals 2x to the power of 2 minus 16x plus 30. Okay, so remember our 30 is going to be our y-intercept. So hopefully that made sense because we just did standard form. Now we have to do factored form. So factored form, we're going to take what we just found in our standard form. So y equals 2x to the power of 2 minus 16x plus 30. And what we need to do is we need to find our greatest common factor. So our greatest common factor here, if we look at all 3 of them, is going to be 2. So therefore, we're going to divide all of this by 2. And we'll be left with 2x to the power of 2 minus 8x plus 15. And then from there, we need to do our B and C. So we have our 2 values here. What is going to add and multiply? We need to multiply to 15. What is going to add to -8, remember? And so what 2 numbers add to -8 multiplied to 15 is going to be -5 and -3. And then from there, we keep our 2 outside. We do x minus 5, x minus 3. Okay, and so therefore we know here our r is going to be 5, our s is going to be 3. And if we were to compare that at the top here, we can see and look at where it fell. So our r and our s were 3 and 5, which is exactly right on track. We checked our work, so therefore our equation in factored form is y equals 2, x minus 5, x minus 3. Do note, something to remember. our A was the same for all three forms. So something to remember, that it was the same for all three. We had the 2 here, we had the 2 here, and then once again, we had the 2 up here. So something to look at in the future when we are going from vertex form to standard form to factored form, it is all three the exact same, okay? Now, let's look at finding the vertex form from the factored form of a parabola. So, when we have an equation in factor form, this is our formula. We've seen it before. We can easily determine the zeros of the parabola, which are represented by the values of r and s. We just saw that, okay? If it is not the typical factored form, which is this formula here, we can find our zeros by setting each factor to 0 and then solving for x. So that's just something to keep in the back of your mind. So when we are trying to find the x-coordinate of the vertex, we have to determine the axis of symmetry. And we know in order to do that, we use x equals r plus s divided by 2. And this, if we use this form, is determining our h. And then in order to find the y-coordinate, we must substitute the x-coordinate into the vertex of the original equation to solve for y, which we know is going to be our k. So that is how we find our k and our h. So let's do an example together. So we have our example here. It's telling us to do it in factored form. Our first step is to look at the equation, what form it's in. It is in standard form. So therefore, given this equation, we're going to rewrite it down here so we can have it closer to us, and it's going to be nice and neat. The first thing is to find our greatest common factor, which is going to be, in this situation, 1. So based off of that, we're just going to use our decomp. So we're going to do our multiply and add. So we're going to multiply here. So remember, it's multiplying these two. So 4 times 2 is going to be 8. So it's going to multiply to 8 and add to 9. So if we're going to look at those two values, what two numbers multiply to 8, add to 9? So 8 times 8, or 8 times 1 is going to be 8. 8 plus 1 is going to be 9. So it's going to be 8 and 1 are our two numbers. So based off of that, let's plug it in. So we have 2x to the power of 2. That stays. Then we use our two numbers, 8x plus x, because 1 is x. And then we keep the 4 because we have to get rid of the 9 because we just used that. And then from here, we want to kind of group it based off of our similar concepts. Okay, so we're going to group these two together, and we're going to group these two together. So between 2x to the power 2 and 8x, the greatest common factor in this situation is our 2x. And between the x and our 4, the greatest common factor is 1. So given that, we're going to say it's going to be 2x stays on the outside, and then what's left over is x plus 4. And then when 1 stays on the outside, we're just going to keep it with the plus, or you can add a 1. We're going to have x plus 4. And then when we group these together, we're going to have x plus 4, and then 2x plus 1. Okay, so that is something that we've learned at the very beginning. Now, we have vertex form that we need to go to. So our first step here is to find our zeros. So in order to find our zeros, okay, remember our equation in factored form. So our equation in factored form was right here. So we're going to plug this information into here. So we're going to keep our one side, x plus 4 equals 0, because remember, one of our steps is if we don't know it, we're going to set it to 0. So we're going to set both sides to 0. 2x plus 1 equals 0. Set both sides to 0 and find. So isolating, x is going to be equal to -4. Okay, so that is going to be our r. And for our s, x, oops, sorry. we're going to move the 1 over to the other side. We're going to be left with 2x equals -1. Divide both sides by 2, and x is going to be equal -1 over 2. Next step here is to find our axis of symmetry, which is also known as our h. So in order to do that, what we have to do is use our formula that we talked about in step 2 here, which is going to be our h is going to be our h is going to be known as our axis of symmetry, which is r plus s divided by 2. So our r was -4 plus our -1 over 2 divided by 2. So what we have to do here is we have to find our lowest common denominator, which is going to be known as 2. So we have to multiply the top by 2 here. Oops. And we have to multiply, because it's always over 1, the bottom by 2. And that is going to give us -8 over 2 plus -1 over 2. So both of them have a denominator of 2 divided by 2. If we add -8 plus -1, we'll get -9 over 2 divided by 2. And remember, in a fraction, it's always over 1. Okay, so in order to flip this, we're going to multiply the 2. So -9 over 2 times 1 over 2. So we're flipping. Okay, we have to flip this in order to divide. So if we're dividing fractions, we flip them and multiply, which will leave us with -9 over 4. Now, let's go all the way up here. Step 3 is we have to sub x equals -9 over 4 into equation to find our y of our vertex, which is known as our k. So using our information, so using our formula that we had before, okay, which was y equals x plus 4, and then we had our 2x plus 1. We're going to sub in this. So we have our -9 over 4 plus 4. And then we're going to have our 2, -9 over 4 plus 1. And now we need to expand. So because we're adding a fraction here, remember this is always over 1. So we have to multiply this by 4 to make sure it's equal on top and bottom. So we're going to have -9 over 4 plus, so 4 times 4 is going to be 16 over 4. And then over here, we're going to expand our 2 into our fraction here. So that will leave us with -18 over 4. And then our 1, same sort of thing. Our 1 is always over 1 as well. And it needs to be over 4. So we're going to multiply our top and bottom by 4. So we'll get, obviously, our adding is going to be 4 over 4. And then we have to add them together. So -9 plus 16 is going to be left with our 7 over 4. Our -18 plus 4 is going to be left with -14 over 4. And then from there, we need to multiply. Okay, so 7 times -14 is going to be -98. 4 times 4 is 16. And then we have to simplify this. So to simplify this, the number that goes into both of them is going to be 2, so divided by 2. And then we'll get -49 over 8. So therefore, our vertex is going to be -9 over 4 from what we found before, and then -49 over 8. Now, step 4. We're almost done. So we need to know A from, standard form. So therefore, our A from our standard form. Okay, if we go back to our standard form, where we were solving for A before, which was 2. So therefore, A is going to be equal to 2. So based off of all this information, our equation in our vertex form is, remember our equation. So our y is equal to our a, which is our 2. And then we have our x. Obviously, we don't need our x. Our h was our negative 9 over 4. And then our k was negative 49 over 8. Okay, so lots and lots of steps that we just did now. If you have any questions, let me know. But it's the same steps over and over again. Make sure you know how to go from vertex form to standard form, factored form. You need to know how to do all of that. That is so important. If you don't have certain values, you don't have that information, you're not given a graph, you're just given an equation, how do you find it? So you have to find your zeros, okay? So if you want to use this chart below, so you expand, you have to go, in order to go to factored form, if you want to go to vertex form to standard form, you have to expand and simplify. If you want to go to standard form to factored form, you have to factor, obviously. And if you want to go to factor form to vertex, you have to find the zeros, find your axis of symmetry and your vertex. So if you have any questions, let me know.